All right, folks, so the first thing I've asked you to do is fill in your squares. While you're filling them in, please circle them just like we did yesterday. All right, so they all should be circled. They're circled because they are the perfect squares. Remember what perfect square means. If you take the square root, it will be a whole number. If you take the square root, it will be a whole number. Is 20 a perfect square? No, 20 is not a perfect square. Is 324 a perfect square? Yes. Is 25 a perfect square? Yes, 25 is a perfect square. All right, so everybody good on your squares here. Okay, let's go to our warm-up, and you should have Desmos pulled up. The reason we have Desmos pulled up, and I'm gonna read across the top here. It says the solution is equal to the root, is equal to the 0, is equal to the x-intercept. All of those things, folks, mean the same thing. Everybody hear me loud and clear there? It's like saying a half is the same as 0.5. Are they the same? Yes, they're just written differently, correct? 3/4 is the same as saying 3/4, is the same as saying 0.75. Any issues with that? So if I ask you to find the 0, all I'm actually doing is asking you to find the solution. If I ask you to find the solution, all it means is actually finding the x-intercept, which is why we have Desmos up. It says one of the roots. Ladies and gentlemen, what does root mean? Root is right here. That's the same as a solution. So one of the solutions is -8. They're telling me. One of the solutions is -8. Well, how many solutions does it have, first of all? You should be able to tell me this by the original problem. That power of 2 tells me there better be 2 answers. They've already given me one, right? They want to know what the other one is. So I'm saying we can use your Desmos because that's the same as an x-intercept. And you all know what an x-intercept is, right? Where it crosses the x-axis. All right, so get your Desmos going there. And I'm going to need you to read off this equation to me because I'm going to have to go between screens here. Oops, hold on a second. All right, I think I'm ready. How we doing, guys? Does everybody see that? Do you have it on your screen? So tell me, what are the x-intercepts? X-intercepts are where they cross the x-axis, correct? That's where it crosses the x-axis? And you're telling me 1.5? You guys hover your cursor over that, and it should tell you 1.5. See how it does? Does everybody see that? Yes? Okay, so if I come back here and I'm going to answer this question, you told me the x-intercepts were -8 and 1.5, correct? Well, they told me the -8 in the directions. I don't see a 1.5 here, do you? I I see fractions. Don't you? So how do I turn these fractions into decimals to figure out which one is 1.5? Divide them. Grab your calculator. Here we go. Negative 3 divided by 2 gives you negative 1.5. Negative 2 divided by 3. Repeating, correct? Okay. How about letter C? Positive 2 divided by 3. And then 3 divided by 2. So, folks, what answer should I choose here? Letter D. Okay. Any questions on using Desmos there? Okay. Let's go on to the next one. I'll be right with you, okay? Which of the following is the sum? Folks, what does sum mean to do? Add of both the solutions. So you see this right here, don't you? Type that into Desmos. Okay, so Autumn had a little bit of an issue typing hers in. Did anybody else have an issue typing hers in? Why didn't you say anything? Why'd you just sit there? Just now? What about the last one? Was everybody able to type the last one in okay or not? No. Okay, so this is me going to get real upset with you real quick. How can I read your mind? I can't. You have to ask me. So when you guys typed yours in just now, it's not letting you. Is that right? Can you tell me what the original problem is? What does it say there? What was it again? When you type yours in like that, it won't let you. Is there like a triangle here with an exclamation point in it? Yeah, we can't have the equal sign in there, folks. So my question to you is, how do I move this over to the other side? You subtract it. It'll be x squared plus 3x minus 54. Now try and type it in. Uh-huh. Okay, I don't know. If you type it in like this, I know that it's not going to give you a problem. For sure, I know that. Does everybody have this typed in now? Okay, I need to get mine typed in. Read it to me again. X squared. Like this. Does it look like that? Or something around there, correct? So what are the two x-intercepts? What are the two answers? What's this answer over here? Negative 9. What's this answer over here? And negative 9 and 6, if you're telling me, are my answers. What was I supposed to do with them? Add them. You get letter G, negative 3. Everybody good? Okay, one more. What are the x-intercepts? So I'm going to go back to Desmos. I'm going to ask you to read it off to me. What's it say? Negative 3x squared. And then what? Plus 7x plus 20. Okay, does yours look like that? Anybody have any issues with that? It all looks like that, right? Okay, so what are the x-intercepts? And 4. negative 1.667, and 4. So if I come back here, well, automatically I can throw out these two, right? Well, you better divide those and make sure it gives you 1.667. Divide them. Does it? Do I want the positive or do I want the negative? You want the negative one? I want letter C from my graph. Questions on using Desmos? Everybody's good with moving something over so you don't have the equal sign if it gives you problems, right? Okay. Close those Chromebooks, put them away. We're done with them. You will see there that we are on day 2 of perfect squares, which is why I just had you write all those perfect squares in. Okay? The better you know them, the better off you're going to be. Okay? So here we go. The first step that you all always forget about still is what? GCF. If there's 4 terms, we group them 2 by 2. If there are 3 terms, you're going to make 2 binomials. You have the short way. When do I use that? We have the long way. Now, the last way is the way we talked about yesterday. If it doesn't start with a 1, don't automatically jump right to the long way. See if you have perfect squares at the beginning and end. And do you guys remember that test we did? You multiply the 2 squares together and then double it. You guys remember that test that we just did? Yes? Okay. That's all your choices if you have 3 terms. There's only one way to do 2 terms. That's the difference, which means subtraction, right, of 2 perfect squares. If you have the difference of 2 perfect squares, you're going to make conjugates. That is now the 3rd time in this class you've heard the word conjugates. Conjugates means the same parentheses, just 1 plus and 1 minus. Everybody good? Are we ready to try some? Yeah? Sure? Okay, here we go. I think that I want to go through and do all the 2-term ones first. Sound like a plan? Okay, so I'm going to start with number 2. Number 2, first of all, do you have a GCF? What can I take out of both of those? Oh, that's not a GCF though, right? We have perfect squares. Is this the difference, folks? Yes, difference means subtraction. So if I have the difference of 2 squares, what am I going to make? Conjugates. If I make 2 conjugates, what 2 of the same number will multiply to 49? What 2 of the same number will multiply for 64i squared? 8i. And if they are conjugates, what does that mean about my symbols? Different symbols. Doesn't matter the order. Okay, let's move over to number 4. Is there a GCF? What can I take out of both of them? I don't think 16 divides by 3. 4 and a squared. If I take out a 4a squared, what's left? There we go. Still two terms in there, right, folks? Is that the difference of perfect squares? Difference means subtraction, which we have, right? Are 9 and 4 perfect squares? They are. So I'm going to drop down the 4a squared, and we're going to make conjugates. What am I going to start with to make 9s? How am I going to make the 4a squareds? And conjugates means I have to have different symbols. Yep. Any issues, folks? No? Where's my next two-term problem? Right underneath it. In fact, this is my last two-term problem. You got a GCF there? No? I'm going to start going around the room here. Let's start back with James. I know you weren't here yesterday, James, but that's okay. Do you have any GCF that can come out of there? Nope. Two terms, right? So is this the difference? And are those both perfect squares? Look on the front of your sheet. Do you have a 64 and a 169 there? Okay, so we're going to make conjugates. How are you going to make 64p squared? 8p and 8p. How are we going to make 169q squared? Not 14. You're close, though. 13, and we got to make sure we put a q on there to make the q squared. And conjugates mean different symbols. Questions, folks? Nobody? So all that's left is three terms, correct? Yeah? All right. Let's go all the way back to number 1. All the way back to number 1. Number 1, does it have a GCF? I'm up to Peyton. You got a GCF? Nope. Three terms, though, right? So I know that the final answer has to be two binomials. Right now, does it look like the long or short way? Long way. But does it begin and end with perfect squares? Yes. What is the square root of 9? What's the square root of 1? Multiply them together. What do you get? Double it. Did you get the middle number? No. But we didn't get the middle number, did we? So can I do it? So what am I going to write? Prime. That one is prime, folks. It won't work. The pattern has to be satisfied if you're going to use it. All right, let's go over to number 3. I'm up to Shane. You got a GCF, Shane? Nope, no GCF. 3 terms, which means my answer has to be two binomials. Right now, does it look like the long way or the short way? It looks like the long way, but I notice that the first and last are perfect squares. What is the square root of 9? And what's the square root of 4? Multiply them together, what do you get? 6, double it, and you get, which matches my pattern. So how are we going to make 9m squared? What was the square root of 9? So 3m and 3m. How are we going to make 4n squared? 2n and 2n. This plus symbol tells me my symbols need to be same and they need to be negative. Good. Good, good. All right, Greg, number 5. First up, do you have a GCF? No. It's 3 terms, though, so I know it has to be a binomial times a binomial. Right now, it looks like the long way. But I notice they are both perfect squares. Okay, what is the square root of 4? And what's the square root of 1? Multiply them, what do you get? Double it. So does it fit the pattern? Yes, it does. So what are you going to start with in your binomials, Greg? And what are you going to end with? And my symbols need to be the same, and they need to be positive. Good. And folks, we've talked about this before, but I just want to hit it again. You could write this like that because there's 2 of them, right? Good? Okay. All right, let's go to number 6. And I'm over to Chase. What do you think about number 6, Chase? It's what? It is math, but what's your thoughts on it? Can we divide all of them by 3, folks? Oh, it's close. The 64, I think, is the only one that won't divide by 3. I'm glad that you're looking for a GCF, though. So we don't have a GCF. Is there anything strange about this problem? It's backwards. So, folks, I'm going to rewrite it. There's still something else that's strange about it, though. It starts with a negative. Y'all see that? So let's take out a GCF of -1. If we divide a -1 out of all this, basically we're just flipping all those symbols. And the way I'm looking at this now is that trinomial looks like the long way. And by multiplying this 9 and the 64, that's going to be a big number, isn't it? But Chase, fortunately, they are perfect squares. What's the square root of 9? And what's the square root of 64? Multiply 8 and 3 together. What do you get? Double it. That matches my pattern here, doesn't it? So I'm in business here. How am I going to make this 9t squared? Remember, they're going to have to be the same because they're perfect squares. How are you going to make that 64, Chase? 8 and 8. This symbol tells me they need to be the same, and this symbol tells me they both need to be positive. Good? Awesome. Number 7 is over to Autumn. You got a GCF here, Autumn? Trinomial, though. Binomial times a binomial. And folks, this starts with a 1, doesn't it? So this is going to be the short way. Autumn, in the short way here, I'm just going to start them with A's. I'm also going to end them with B's because there's a B squared on the end. I need factors of 4 that will add to 2. Factors of 4 that will add to 2. What do you think, Autumn? Nothing works, right? The only factors of 4 that I know are 4 times 1 and 2 times 2. Do any of those add to 2? So what am I going to write here? Prime. Okay. And I believe I've only got one more row left. Yeah? Okay. Let's go to number 9. And I'm back to William. William, can I take a GCF out of there? Definitely an N. There's something else besides an N, though. What number can I divide out of all of those? Unfortunately, it's not a 2 because that 63 won't divide by 2. It's not a 4. The 63 won't divide by 4. It can't be anything even because 63 is not even. That 63 is the hang up here. 3, I don't think 28 divides by 3. Well, let's try the odd numbers. What'd you just say? 7 will work. So we're going to divide by 7n. What would be left, William, if we divide by 7n? Good. Binomial, right, folks? Long way, right, folks? Unless you notice, these are both perfect squares. William, what's the square root of 9? What's the square root of 4? Multiply them. Double it. Does this match our pattern, folks? It does. So, in fact, I don't really need to do the long way. I just need to use my perfect squares. How are we going to make that 9n squared? And I'm going to put an n on it, right? How am I going to make that 4? And then this tells me the symbols have to be the same. That tells me they have to be negative. Perfect. Wonderful, wonderful. Okay. I think I'm good. Okay, on this section. If you want those last 3, you can do them for extra credit. Okay, let's go down to the bottom section now. Notice that all of these in the bottom have what in them? Equal signs. So I actually have to solve them. Okay, notice I have like 2 columns. Do you see how it says solving quadratics 1 and solving quadratics 2? Yes? Okay, we're going to start with the easy ones. Let's do solving quadratics 1. All problems in this column have blank type of variable. Look down there. How many types of variables do all of those have? They all have one type of variable, meaning they either only have x's or they only have x squareds. They don't have like both of those in the same question, do they? No, it's either just an x or just an x squared. If we have that, we can do it the way we know how, which is by isolating. And you all know how to isolate variables, right? Do the opposite of what you see. There's one trick I need you to know, though. Remember, when taking the square root of a variable, you must use a plus or minus symbol. And I'm going to show you what that means here in a second. Ready to go? I think I left off with William, so I'm back to Jason there. Jason, you see how it's just an x squared there, right? I got to isolate the x, which means I got to get rid of the squared. What's the opposite of squaring something? It's a word I said a lot today. Opposite of squaring something. Does anybody know? What do you think? It's kind of like dividing, but not quite. Square rooting it. Square rooting is the opposite of squaring. Are we good with that? So, Jason, I'm going to square root both sides. When you square root both sides, the squared cancels. So, Jason, what would be left on that left-hand side then if I just canceled out that squared? Just an x. And then, Jason, what is the square root of 64? 8. But I told you up there in our notes, be careful, because when you use a square root symbol, you have to put a plus or minus in front of it. Because, ladies and gentlemen, this squared term tells me how many answers should I have? 2, which means now positive 8 is an answer and negative 8 is an answer. So do you see how there are 2 answers there? Okay, moving over to number 2, and I'm over to Ray. Ray, there's only a y squared. So how do I isolate that? Not yet. I got to get the y by itself first. So what do I got to move over? How do I move that 169 over? We have to add it. How's everybody doing? Good. Now, Ray, how am I going to get that squared off of there? Not squared again. Square root it. So we're going to do this, which means that squared cancels. So, Ray, what's left on the left now? And then what's the square root of 169? And remember, if I'm going to square root it, I've got to put a plus or minus symbol on it to get my 2 answers. What do you guys think? We doing okay? Yes, remember how to isolate, I hope, right? Okay, let's go back to the beginning, which is back to James. Number 3, James, you see how I only have a d squared there? I got to isolate it. What's farthest away from the d squared on the same side? How do you cancel out that negative 81? Okay. So now I have 9d squared equals 81. Now what do I have to get rid of, James? The 9. Yep, and the 9's being multiplied. So what are you going to get rid of? Or how are you going to get rid of it? So d squared equals what? That's okay. 9. Now, how do I cancel out that little squared up there? Square root it. So now I have d equals, what's the square root of 9? What times what equals 9? 3. And folks, because we square rooted it, I need a plus or minus symbol on it. How we doing? Just fine? All right, Peyton, how do I isolate that a squared? By what? By 4. Now, don't be scared of this, folks. Your calculator will do that division for you. What's 9 over 64 divided by 4, Peyton? Okay. Now, how do I cancel that squared out of there? Square root it. Okay, so now I have a equals, and I'm going to put a plus or minus on it. Now, you can type that into your calculator, and it will give you the answer. But if we square root a fraction, it's the same as square rooting the top and square rooting the bottom. So what's the square root of 9? And then what's the square root of 256? There we go. There's our answer. And again, your calculator would do that, but if you've got your squares there, it's just as easy to find them. Okay. All right, number 5, Shane. Right here. This one's a little different now, folks, right? See the parentheses? Do you see how the squared is around the whole thing? So, Shane, I need to get rid of the squared first. By doing what? By square rooting it. So I have y minus 6 because it canceled out that square. How we doing, guys? Brand new stuff today. Is equal to plus or minus, what is the square root of 81? Should be 9. Now, how do I isolate the y? Add the 6. Now, folks, this looks a little funny because I have plus or minus 9, then plus 6, right? Shouldn't I get 2 answers? So here's how we get those 2 answers. What is a positive 9 plus 6? And then what is a negative 9 plus 6? And those are our 2 answers. See how we work that? Yeah? Yeah? Okay. Another one is for Greg. Same way, Greg. I got the parentheses with a square around the whole thing. So we'll square root it. Now, 32 is not a perfect square. Can everybody do the square root of 32 on their calculator? It's a huge decimal, right? So what I want you to do is just leave it as a square root of 32. Is that okay for everybody? All right, now, Greg, how do you isolate the b? So now I have b equals this plus or minus square root of 32 plus 7. And now we're actually going to find our answer. So do you still have the square root of 32 on your calculator? Okay, now add 7 to it. What do you get? Just give me like two decimal places. What is it? 12.65. Okay. Now, let's do the negative square root of 32. Type that in your calculators, folks. The negative square root of 32. Then press equals. Negative square root of 32. Press equals. And then add the 7 on. What you got, Greg? There you go. Doing okay? Sure? All right, we'll do 2 more and then we'll call it a day, okay? All right. Chase, what am I going to do first? What's farthest away from the x on the same side? Okay, I'm on this one right here. You see how the x is in with the plus 9? And then that's squared, and then that's multiplied by 2. I got to get rid of this 2 first. How? What's happening between the 2 and the parentheses? So what are you going to do? Yes. Folks, do you see how I'm getting rid of this front 2 first before I get rid of the squared? Yes or no? Okay, so I have x plus 9 squared, and then I think that's 8 over there. Okay, now how do I cancel out the little squared, Chase? What's the opposite of squaring something? Somebody help him. What's the opposite of squaring something? Square root it. Unfortunately, 8 is not a perfect square. So we're just going to leave it like that for now. Okay, how do you get rid of this plus 9? So now I have x equals plus or minus the square root of 8, then minus 9. So now we're ready to find our answers. Calculator? Here we go. You probably don't know how to work his, though. Square root of 8, folks. Come on, you guys can do this. Square root of 8. It's a big number, right? And then you're going to subtract 9. Good? How we get that? Good? Okay, now you're going to do the negative square root of 8. The negative square root of 8 equals, is that big number again, right? Then subtract 9. Perfect, James. Perfect. How we doing? Good? Now, the whole reason we did all this is because every one of these problems only had one type of variable in it, right? Now, I'm not going to get to do these, which is fine, but I need you to recognize these things have 2 different types of variables. One's an x squared, one's an x, right? You've already learned how to solve this. You factor it, then you set them equal to 0 and you solve it. Do you remember doing that this week? I hope so. You will add the 1 over, then you'll factor it and you'll solve it. That is nothing new to you. That column was all old stuff. Are we clear on that? Okay. You need some homework here. Page 520. Numbers 48 to 51. And then I also want you to do page 526 to 527. Just numbers 10 and 35. So that is 6 problems for you tonight.